So let's see properties of fluids. The first one is density or mass density. Density or mass density of a fluid defined as the ratio of mass of the fluid to its volume. So this mass per unit volume of fluid is called density. That's simple, right? We have density, which is mass of fluid over volume of fluid. So its units are kilogram per meter cube. Temperature increase with density decrease. Here the main thing that we have to have is temperature increase with density decrease. We all know when the temperature increases, obviously the density increases. So we can say the solids are higher dense than the liquids, right? The liquids are higher dense than the gas. The other thing, pressure increase with density increase. It's also another thing. So you can just read it by yourself. We have this, we all know PV is equals to MRT. This universal gas constant values is here, and molecular density we have this, air density we have paraffin oil, this one. So we can calculate estimated density from characteristic gas equation. It's like if you want to know the density, you can stand from the characteristic gas equation, which is this one, by taking these things as an input. The other thing is specific weight or weight density. Specific weight or weight density of a fluid is the ratio between the weight of the fluid to its volume. We have weight of the fluid to its volume. The weight per unit volume of a fluid is called specific weight or weight density. So we call it specific weight or weight density, which is the weight per unit volume of the fluid. It varies from place to place because of acceleration due to gravity changing from place to place. So specific weight is equal to weight of fluid or volume of fluid. We have the weight, we have the volume, and we all know weight is mg over v, right? So we have the m over v, which is g. So we can make this one like this. I think you got my point, right? So let's say the specific weight is the small w, which is equal to weight of the fluid over volume of the fluid. So we know weight is mg, right? We have weight mg. So we can call this specific weight or weight density. It's Newton per meter cube. So here also temperature increase with specific weight decrease, and pressure increase with specific weight increase. The other thing is specific volume. Specific volume of a fluid is defined as the volume of a fluid occupied by a unit mass or volume per unit mass of a fluid. So you can take V is equal to volume of the fluid over mass of the fluid, and its units are meter cube per kilogram. And we have specific gravity or relative density. The specific gravity is defined as the ratio of density of a fluid to density of a standard fluid. So we can take this specific gravity or relative density is equal to density of a fluid or density of a standard fluid. Most of the time, as an example, you can take the specific gravity of mercury is 13.6. We can get it by dividing density of the fluid over density of the standard fluid. Interesting topic is viscosity. Like this, the property of a fluid due to cohesion and interaction between, like it occurs due to cohesion and interaction between molecules. Viscosity is a property of a fluid due to cohesion and interaction between molecules, which offers resistance to shear deformation. Different fluids deform at different rates under the same shear stress. Fluids with high viscosity, such as syrup, deforms more slowly than fluids with low viscosity, such as water. If they have high viscosity, they can easily deform, but if they have low viscosity, they deform slowly. So the main thing that I want you to have here is, what does viscosity mean? Viscosity means it occurs due to cohesion and interaction of the atoms, or the cohesion and interaction between molecules, which offers to resistance to shear deformation. This is viscosity. So you can take this one, this figure as an example. So viscosity defined as a property of which offers resistance to the movement of one layer of fluid over adjacent layer of the fluid. It's resistance. When two layers of fluid, let's say a distance dy apart, move one over the other at different velocities, say u and u plus du, the viscosity together with the relative velocity causes a shear stress acting between the fluid layers, right? And also you can say this shear stress is proportional to the rate of change of velocity with respect to y. And the other thing is dynamic viscosity. We were talking about viscosity, right? So we have dynamic and kinematic viscosity. Dynamic viscosity is defined as shear stress required causing unit of shear deformation. Unit of shear deformation. We have the shear stress here, right? Over the unit rate of shear deformation. This one is unit, or you can say point is unit for dynamic viscosity. The other one is kinematic viscosity. It defined as the ratio of dynamic viscosity to mass density. We have the ratio of dynamic viscosity to mass density, which is we call kinematic viscosity.